Right. There is no microphone. I hope you hear me well. I'm Piotr Tykarski from GBIF node of Poland. I'm going to present you some slides on the data management and presentation system we've been working on for a few years. It's almost ready. You can see I will give you the address. You can see them. It's online. This is the work of the effect of cooperation within Polish Biodiversity Information Network. And it's controlled or steered by the GBIF-PL team. I hope it works right. I have lots of slides, tons of slides to show you, so I'm a bit nervous, sorry. This 4 will be okay, but then I will have to speed up. So we accumulated data from several digitization efforts based on collections, observations, bibliography. Right now it is about 10 million records, including 2 million specimens. We have more, but it's a process. It's a contribution of 18 institutions. We have a special focus on taxonomy, so we also collated the checklist of all eukaryotic species from Poland. It's more than 60,000 of accepted species. We also managed to collate the taxa from occurrences not belonging to the Polish fauna and flora biota. We have two basic applications. I will show you portal biomap.pl. Biomap stands for biodiversity map, but biodiversity map would be too long, so biomap is a shortcut. And the second application is, of course, IPT, with which we publish our data to GBIF. Technically, the database works in PostgreSQL environment. Backend is based on PHP Laravel, which is surprisingly live still. And they flourish now, and front end based on Vue.js and open layers. It was too fast, too quick. Right, and we integrate rich data sources. Taxonomy, I mentioned already, but bibliography is also a must for us. So we have a special set of tables for this purpose. The system is going to serve the presentation and visualization, and we are going to easy access and search and filtering for the users. And the core of the system are relations between data objects, data categories. So the data are we present as data views, so-called perspectives. So there are perspectives here: taxa, occurrences, publications, collections, authors, data sets, locations, and checklists. So there are data views for the same database, showing the content from different angles. Data management is a challenge, of course. To do it efficiently, the user should have different levels of access rights. So we have six levels of these access rights, and institutional data sets will be mapped actually to IPT and published in GBIF. Checklists cover the whole biota of Poland. It is called Digital Catalog of Biodiversity of Poland. It's published in GBIF also. It covers all eukaryotic species plus cyanobacteria, and we also pay special attention to authors at different points of attachment to the data. There are six levels of occurrence data, more or less like in the new Darwin core data package. So sample, occurrence, individual specimen, material sample analysis. It's nested structure. The taxonomy tables are based on ITs. And bibliography fields were more or less complementary to BIP text, but it was of help for us to standardize it somehow. And currently, we are in the final phase before the tests with a with a selected group of users. We have to prepare and work hard on mapping data, mapping interface. And soon we'll be transferring the data from the old legacy system we have in hand, but the server is dying actually. And finally, we are going to include all data sets published so far by GBIF-PL in the future. So now I will speed up a bit. I hope it works. I'm going to show you the screens from the system. So this is the home page with some basic statistics of different data. Of course, it will evolve. Now, something about perspectives. So taxonomy is a core. So we can switch the view of taxa. These are taxon perspective. So we can see taxa either as a tree or as a list. And if I browse through that tree, I can on the right panel we see details of every single object. So we have now seeing a gallery of specimen pictures at the Tracheophyta level. Now at the ranunculus, in order within a group, then we can go deeper to the level of. Then we can switch. We can check one of the pictures and see the details. So it can be magnified. Then, if I click here, I can see go to the details of the taxon and set it as a filter for the whole. And now it will be set as a filter with which we browse through the rest of the system. So now we are still in the taxa perspective. Now I switch to the occurrences, and now I see only occurrences connected with this particular taxon. So I can look at different details of this particular occurrence. It is a specimen. And I'm just now browsing lower here, like scrolling the right panel. So I can see that the occurrence locality, magnified somehow. This is a very simple interface at the moment. Now the rest about information about location. And now we switch to data sets. I see data sets containing only this particular taxon. Now I switch to the details, and I can make use of data relationships within the system. So I can see the taxa connected with these particular data sets, some basic information about occurrences, and it is scrollable, so there is much more data which is available for the users. Now we are in publications. At the moment, it's just one publication connected with this species, which of course not true. It will be more in the future. Again, I can see now details on the what is connected with what are the contents of the database associated with this particular publication. So I can see species and get some summary of other objects connected with it. Now I can see locations connected with this particular taxon and checklists containing this taxon, which is of course vascular plants, and I can also browse through these taxonomic lists to see to search for a string of interest. And these are details. These checklists are quite well developed, containing the reference documents about the species occurrence. So now checklists, a bit more about checklists. Checklists contain all species in Poland, and they are connected with, they are published in GBIF. So if I click here, I'm going to the GBIF portal. And something about filters. Filters are really overdeveloped, I would say. They are very complex. And sorry, and I can I went to, okay, yes, and there, now I set a string of a taxon name as a filter. So now everything filters, adjusts accordingly to the filter set. So now I see occurrences containing the species with this string, and now data sets. I can click here and go to the data sets again and see the details about the data set. And again, it's linked to to GB because all our data sets visible at this stage are connected. Now a bit about authors. Authors have, when possible, they have ORCID and ORCID ID, and they set to different roles, so it's important to categorize them. And it was something about the editing module, but I have no time anymore. Thank you very much.
All right, thank you, Piotr. Unfortunately, we don't have time for questions, but I was told that one of the sessions the presenters isn't here, so hopefully we'll have some time at the end. So the next speaker is Danielle Seymour from the South African Environmental Observation Network, talking about their open data platform. This is forward. I think you might have to stand over there because this is just for the translation. You can try it from this side.
Okay, hopefully works. Okay. He said wait. Yeah, he said wait. I think he's busy because he said I should wait. I don't know. There we go. Okay, let me just test if it's working. Yes, great. Good morning, everyone. My name is Danielle Seymour. I am from the South African Environmental Observation Network, where I serve as a curation specialist. And today I'll just be talking a little bit about some of the work that we've been doing to try and lay the foundations for publishing our biodiversity data in an appropriate standard in our open data platform. So just a quick background of SAON. We are a research facility of the National Research Foundation of South Africa, supported and funded by the Department of Science, Technology and Innovation. And our job really is to support long-term environmental observation across all of our biomes and to our oceans and coasts, as well as the southern polar and subantarctic regions. And this also includes the Prince Edward Islands. We essentially make environmental and Earth observation data available to the public, also accessible and usable, and we also provide the infrastructure that allows research to happen. SAON operates across 7 nodes across the country, each with its own focus, and I am based at the data and ICT node, which basically just provides all the services and the infrastructure to allow the data to flow within our systems and the organization as well. So SAON, like many research infrastructures, collects an incredible diversity of data, from hydrological data to vegetation, species observations, marine, as well as atmospheric measurements. And as we know, environmental science by its nature produces massive amounts of data. And the challenge with that is many of the data sit in different repositories using different standards. And that fragmentation severely limits how well we can monitor and understand our ecosystems holistically. So, on top of that, researchers also use many different metadata standards. So for example, you might have geospatial data using the ISO 19115 standard. There's DataCite, there's also Darwin Core for biodiversity data. And as the Data One initiative highlights that all these different standards need to be harmonized in order to make integration even possible. And without the common mappings or the bridges between these data, the data sets remain siloed. And it's as if each research community speaks a different dialect of the same language. So the SAON ODP was designed to break down those silos. Currently, it supports the ISO 19115 standard for geospatial data, as well as DataCite. And we are now extending it to handle EML for our biodiversity data publication. The portal is Core Trust Seal certified, which means that it meets international standards for trusted digital repositories. And it's also built on the FAIR principles, which we know means the data to be fair, findable, accessible, interoperable, and reusable. And in practice, this means that our system uses agreed standards and APIs so that both humans and machines are able to retrieve our data reliably. So what did we actually do in order to connect these different metadata worlds within our ecosystem? We used what's called a crosswalk, which I'm sure many of you are familiar with. And what it does was it's a way to enable semantic interoperability, meaning that the systems share meaning and not just labels. So the approach that we used was a matrix mapping method, which aligned the existing ISO 19115 DataCite and then to include the EML. So basically, I was given this really big, daunting spreadsheet with the existing metadata profile for SAON, and I had to incorporate EML into that. And within that sheet, basically each column represented a schema, and each row is a shared concept or an element in the standard. So as daunting as the spreadsheet was, this method really gave a clear picture of the relationships and the complexities between the different schemas. For example, some mappings were very straightforward. So an example would be title. That was relatively easy to map across the standards as it had a one-to-one relationship. But then there were also more complex mappings where, for example, in ISO, one element might map to multiple EML elements and vice versa. So the challenge with that is that crosswalking isn't just about matching fields. It's a process of conceptual negotiation. And the challenge really is in the differences of scope and granularity between the different standards. So ISO, for example, is highly detailed, DataCite is quite flat and minimal, and then EML is very domain specific. And what I also found was that obviously all the fields do not exist across the schemas. And even when they do, their vocabularies may vary. But the key really was in preserving the detail as much as possible while keeping things compatible and meaningful, or basically maintaining metadata integrity. So once I had completed this mapping, it was handed over to our systems development team, who have now incorporated it into the back end of our ODP. And some of this work involved generating a JSON schema to support the EML, extending Python classes for new metadata fields, and configuring the configuration of YAML configurations for flexible ingestion, and also our validation system was upgraded to ensure adaptability to future standards. But yeah, in all of those very jargony development terms, it basically meant that the crosswalk became a functional layer within our system to support integrated metadata. So through this process, we learned quite a few lessons. Firstly, to define the purpose early of the crosswalk, because the end goal really determines how deep the mapping should go. Secondly, to document every decision, especially the non-obvious mappings. And this was something I really wish I had done sooner. And famous last words of any data curator or person that works with metadata, future you will thank you later. And finally, to accept that metadata work is iterative. It's as much interpretive as it is technical. But I think the biggest lesson for me that I learned throughout this process was that perfect interoperability isn't really the goal, but rather useful interoperability. So why does this work matter? Our ODP integrates a variety of data types from different data sources and data providers, really to create national products that support and benefit society. So I've listed some of the products that we have or have collaborated with other government institutions. So the South African Risk and Vulnerability Atlas is one. There's also the National Climate Change Information System and also the Bioenergy Atlas of South Africa. But also I think importantly is that integrated metadata doesn't just support researchers, but knowledge for society and also sustainability. So, as we continue developing our ODP, our focus remains on building lasting and interoperable data infrastructure. And technically, that means expanding to fully support all data types, and for us, biological data or biodiversity data. Strategically, it means bridging data cultures and fostering collaborations. And conceptually, it's about connecting science, systems, and policy. Because in the end, building data bridges isn't just about connecting systems, it's also about connecting communities. And with that, I thank you and invite you to visit our SAON catalog, just to browse and see what data products we have to offer. And also, if you are keen to get in touch with any of our teams, I'm happy to also chat because I'm quite keen to get insights from anyone who has done any similar work. Thank you.
All right, thank you so much, Danielle. Unfortunately, we still don't have time for questions. So the next speaker is Patricia Kolev from Kona Bio in Mexico, talking about biodiversidades.
Thank you. There are some places in the front if you want to sit. I'm not going to move. So on behalf of my colleagues in Conavio, with whom I'm coordinating this big effort, and some of our collaborators in different universities now, but mainly from National University of Mexico, I'm very happy to present this brand new platform we're just to release with the Ministry of Environment in some time. Conavio has the mandate, Conavio is a governmental institution that has the mandate by law to build the National Biodiversity Information System. This is part of GBIF, but we don't also have the mandate to put lots of data. We need to provide advice to the government and to make available the biodiversity information for many different public, not only the government, but we have developed materials even for children and to raise awareness about biodiversity. So when Conavio has a lot of information, probably many of you remember that the Millennium Ecosystem Assessment was released for the new millennium to see the state and trends of biodiversity. And it was fantastic, but very broad. You cannot really not use almost anything in a national, for any national politics and program. So we inspire in this ecosystem assessment, and in fact we developed the first ecosystem assessment at a national scale before IPBS. And you must see, this is like 14 kilos of books with a very broad participation of about more than 800 people, 700 authors, and a lot of peer review partners from many different institutions. And we developed some executive synthesis for politicians. And the days that we have the different syntheses were key for new governments and to send it to senators and to take into account what are the main challenges that we're facing about conserving biodiversity. And many people, this has a lot of consultation, not only in scientific papers. Many people is continually asking, oh, you know, I saw this graphic in this book. Do you have an update one? We cannot produce, again, this kind of books, and we're not willing to have more paper use. So we decide to create an interactive and dynamic platform to have this outlook of Mexico's ecosystem assessment which involves not only the work that we do in Conavio with our National Biodiversity Information System, and other systems that are related, because we have a spatial space monitoring system of mangroves, we have alerts for fires, we have a lot of systems running around this biodiversity information system, but from other institutions. And this platform is going to have with different sections. I'm going to show you. Just we have this thematic organization. We have a dashboard, geospatial dashboard, and what we call a summary, when we have some study cases and some numeralia to have some issues that can be measured in another way. So instead of having the five chapters we have one developed to knowledge, to global change, to sustainability, and for scenarios that went this way. Okay, and we have some subsections, and it's going to be searchable with keywords. And the idea is now you are in the dashboard, you are in a section, and it will show all the results, but you also can filter from different aspects you are interested in. You also can type some keywords, and this is the type of information. If I would like to see the plant data in the SNP, but then you can see the completeness of this data in different resolutions for different groups and the estimated richness. But the idea is not to present just the nice map. The idea is that every indicator has a key message for decision makers. It has the methods. You can withdraw the data if you are interested. This is very important for transparency. It's not something that I say because I have the data, but you don't know how I get through it. If you want to repeat the analysis, you are very welcome to repeat it. And so far, we have a lot of special things like the dashboard. You can select the unit you want, can be a protected area, can be an estate, can be a basin, have the trends in vegetation or whichever, have the graphics. We're going to have in this thematic summary some case studies, and you can download the report that will have, of course, the indicator name, the key message, that is for make it clear for decision makers, and the description, the methods, the notes, the links, and all the references. So we think that with this platform, we are going to help to support the public policies to report to the Cumin-Montreal goals, also the sustainable work. And here are some reference of the things we have published since we started doing this national assessment. It has a big launch, and there are lots of outreach resources in Spanish. And so with that, it's coming soon, the platform itself. Now you will be referred to Natural Capital, the books, but it's going to be very soon because we would like to have the ministry making this big announcement of this platform. So thank you very much.
I think we have time for one question.
Yeah.
Yep.
Patricia, thank you so much for that. That was really amazing what you're doing in Mexico. And so I'm curious, has going from books to a website made your production team more efficient or less efficient in terms of like the number of people involved?
It is, of course, more efficient. We do not have all the indicators that are already in place. We started with all the things that we have in Conavio and trying to connect automatically to have many of the graphics. But we're going to involve more people, but definitely it was a huge effort. And in the platform, we have all the programming and the GitLab. It's going to be open, all the development to anyone. Thank you.
Thank you so much. Our next speaker is Andrea Taurello, talking about LifeWatch Italy.
Yeah, thank you. And good morning, everyone. So, yeah, I'm going to present this national research infrastructure, which is LifeWatch Italy. Just to frame a little bit better, LifeWatch Italy is one of the 8 distributed centers of LifeWatch ERIC, which is European distributed research infrastructure consortium. And our main aim is to be a national hub and provide a main point of access to fair and open data and, in general, all the digital research products that are produced during the research life cycle in the field of ecology and biodiversity, and to provide also digital services to support this life cycle. To do so, in the last 4 or 5 years, we developed a full ecosystem of interconnected platforms, and each of these is supporting one or more steps in the data management life cycle. So we have platforms here, bioacoustics and citizen science platform for the data collection. Then we have the data portal and a metadata catalog to support the data preservation and metadata reuse. We have Data Labs, which is a platform that supports analysis of data. And here we also maintain the Italian taxonomic backbone for the creation of taxonomic data. And then we have a semantic platform for the annotation and eventual integration of data that are deposited into the data portal. And then we have a training and help desk that are more like transversal services to support reuse of all these services and the data within. So as you can see here, some of these platforms are already connected. So that means that, for instance, if you deposit something on the data portal, then it can be automatically retrieved by Data Labs, so you can use it for doing data analysis, or the metadata are directly dropped in the metadata catalog. But now the idea is to go briefly through each of these, so to show the main features of this platform. So for data collection, as I was anticipated, we have these 2 platforms that are mainly for data collection from the citizens. So the bioacoustic platform is to collect, recognize, share, and search acoustic data. So the most obvious example are the birds, but at the moment we are trying to increase the knowledge base to give more data to the training model behind the platform, to allow the platform to recognize also other natural sounds. And then we have the citizen science platform that is for sharing knowledge and tools, training materials on citizen science activities. But the most, I believe, interesting feature is that it allows the creation of web application from scratch for free directly into the platform. I gave a presentation on this yesterday, so I think the PPT is now available on the website of the conference. We have a data portal, which is, I would say, the core of our ecosystem platform, because it's the main entry point for the data. In principle, we accept all data types, but it must be in open formats. We use the EML as metadata schema. And then the exciting thing, well, exciting, for me it is exciting, is that we connected the data portal with the Eco portal, which is a repository maintained by LifeWatch ERIC for semantic artifacts, so ontologies, Tasari, vocabulary. And then when you type into the keywords or into the data tables of your metadata, your words, a drop-down menu starts suggesting you some terminology that comes from the Eco portal. Okay, so in this way, you can annotate your metadata with controlled terminologies, as in this case, for instance. This is a data table, which is just the list of header of the variables of your data set. And then you have the label, the definition. Most importantly, you have a URI so that this is fully machine actionable. This allows the mapping of the metadata against our ontological model, and then thanks to the Italian semantic platform, you can then query the data and eventually integrate them. We have, of course, when you put data into the data portal, you start a workflow of data curation that check primarily that the data are in the schema of Life with Italy, that is based on Darwin Gore, by the way. And then you have, if you have a scientific name in your data, you have a taxonomic check. Here you can decide to control against international backbones, or we, as I said, we maintain an Italian taxonomic backbone, so you can decide to check and validate against this. This is a very cool initiative. This is always under the umbrella of Life with Italy. We involve more than 150 experts, taxonomic experts in Italy, that help us to maintain this resource. Data Labs is our platform for collaborative coding. It supports Python, R, MATLAB, and here anyone can open a new project, invite your colleagues to collaborate on the same code. You can recall data from the data portal, or you use your own data. Then, when you are done, the nice thing here is that you can publish it as a service, so that other people that are coding in the platform can recall your service, or you can ask to publish it as a web service, so it becomes available for other people that doesn't have the skill to code, to use it from a web interface. Then, last but not least, our metadata catalog here. Obviously, we have all our resources that are exposed from all our services. Potentially, we can also harvest from other infrastructure. This is the type of metadata that we are exposing right now, but probably it will increase in future. All these things are also then exposed on the Life4Sharing metadata catalog, and this is very important for us because it boosts a lot our visibility, because this is then connected to the European Open Science Cloud. But we can also expose our metadata on other catalogs. This is just an example from a national project, which is like a national portal for research infrastructure, and we are exposing now our metadata also there. So last words on future developments and consideration. We are aiming at a unified ecosystem of platforms. Right now, we have single sign-on to access all the platform. We have interconnection between some of them, but in the near future, we are developing the connection between bioacoustic, citizen science platform, and data portal and metadata, so that when you have data, you can directly drop into them. We register a positive growth. This is quite new, so we are planning a dissemination at national level to try to boost the adoption of these platforms. And last word, just to remember that this is costly infrastructure, so we need funding, investment in the infrastructure and also on the people that work on it. Okay, in the last slide there was the link to the paper that explained all of this. That it is not appearing, so just write an email and I'll send you. Thank you very much.
All right, thank you, Andrea. Super cool stuff that you're doing. I think, yeah, maybe we have time for one question.
Yeah, thanks for this talk. Quick question. EcoPortal, is this an instance of OntoPortal? So can you pull ontologies from other domains via the network, from BioPortal and so on?
It is an instance of BioPortal. Now, she is the expert of this. Sorry to put you on the spot. And Ilaria is here, sorry.
Okay, we are inside the Alliance Onto portal where there are different instances One of these is EcoPortal. So our idea is to not replicate the same resources, but to we create a kind of onto-portal federation where you can query and query the different instances. So not only EcoPortal, but also BioPortal. Yeah, yeah.
All right, our next speaker is Peter Desmet from the Research Institute for Nature and Forest in Belgium.
Hi, I'm Peter. I don't want to talk about platforms. I want to talk about the data standard. And I'm going to give an introduction to data package. So it's a frictionless data 101. So let's say you got a CSV file from a researcher and you want to publish this on Zenodo. What would be useful is that you can describe the columns in that data file. So I have a CSV file here with bird and tag deployments. You want to describe the data types. Are there any constraints? And then the question is, how do you do that? Do you do that in the metadata of that data set? Do you add a README text file? Basically, whatever you're going to do, your approach is going to differ from mine, making it hard to find those descriptions or to machine read that data. And also naming things is hard. So do you call these columns? Do you call these fields? Do you call these terms? This is where data package comes in. So data package is a standard to describe data sets, data files, and tabular data. It is generic, so not like the community standards or the technical standards that we have here. It is by design very generic. It is simple, it's extendable, and it is open. It is hosted by the Open Knowledge Foundation in a project called Frictionless Data, which is why this is also often called the Frictionless Data Package. And just like that WIC standards, this is maintained by volunteers. So how does this look like? To create a data package, the only thing you need to do is add one extra file to those CSV files, and that file is called a data package JSON file. In the terminology of data package, it's called a descriptor file. And it serves as an access point to all the CSV files that you have. For example, here I have a data package JSON file, and I have a number of CSV files. Some of them are zipped, but your data package JSON file can act as the access point to all those files for software. And in that data package JSON file, you can describe many different things at different levels. The first one is at the data set level. Then you can go into the file level. Then you can talk about the CSV properties of those files. And you can even describe the terms or the columns in those files. So let's go from top to bottom. This is on the right, the content of one of those data package JSON files. And what I have here, the minimum you need is a resources property, which is saying this data set consists of these resources. In this case, I have two. I have reference data and I have GPS data. As you can see, the GPS data is referring to two files. So as long as that format is the same, you can bundle files together as one resource. There's many other terms you can add at the data set level, which is a bit similar to EML or data site. So you can add your contributors, a license, or your own terms because it is extendable. If you go look at the single file, so here I'm describing reference data. It has a path to that file, meaning that software can find it. You can describe what type of data this is, the format, media type, the encoding, and especially for CSV data, you can also indicate something called the table dialect, saying this is my delimiter, I have a header file, there's comments in there. So those are all things you can describe very in a way where you don't have to invent those terms. All those terms are here. So there's a standardized way of describing files. So that's the data resource specification and the table dialect specification. We go one level deeper to the tabular data. You can describe all the fields you have in your file. So here I'm describing those file fields. You can also indicate primary keys and foreign keys. So if multiple files that are related to each other, that is also something you can describe, as well as missing values. And then finally, if you can go into one single field. In addition to the name, you can add a more human-friendly title, or what is in Darwin Core called a label, a description, an example, and then very important, you have a type and a format, so you can indicate for each field or each column what data type you have in there. And also very powerful are constraints, where you can say, well, this term is required, this is a minimum and a maximum value that I'm expecting for a decimal latitude, for example. So all of those are things you can specify as part of the data package standard. So in the end, what I have by adding this data package JSON file is I'm creating fairer data. I mean, it's already fair by publishing it on Zenodo on the dataset level, but now also on the data or on the file level itself as well, because you have rich metadata, you have one access point, you have standardized ways of describing things. So my approach is now your approach, which is nice. How do you make a data package JSON? There's a number of open source software available. If you want a desktop UI tool, there is the Open Data Editor, where you can describe all the fields you have in your CSV and all the metadata. There's two packages that are really useful in more like operational environments or in R and Python. And there's a new kit on the block called dpkit, which also offers ways of creating data packages, of reading data packages. Our team at IMBO is maintaining the R package. And what really drew me into data package is the validation option. So all those terms and all those things you have to find, there is software out there that can just do frictionless validate data package JSON. It's one line on the, in the terminal, and then it's going to go through your whole data sets and figure out, are there metadata errors? Are you using terms here that, for example, I'm adding license, but I'm not properly providing the licenses there. Am I referring to files that are not there? The type errors are super useful. So for example, here it says that I have a type error that date over there does not fit with the format because I forgot the 0 seconds. So when I'm receiving a file from somebody else that is a data package JSON file, the first thing I do is run this validation to see, like, are there any structural constraints or errors in there, and then get back to the person who gave it, like, you need to fix this, or at least I know where I have to fix things. Also, when I'm publishing things, I can do the same. And for example, the last error that you have there is, well, you had a column animal sex, you provided X in there, but that does not meet the constraint that it needs to be F, M, or U. So it's very powerful to have this validation just be there for free. And then a next step you can do is, well, this is now for describing your own data sets. You're not following any community standards, except you provide a structure to make it easier to validate. But you could go one step further and say, well, we have similar data sets, why not describe that into a profile, and what our expectations are of our data sets, and what our expectations are in the tabular data within those data sets. So the first one would be a profile, and the second would be table schemas. And by doing that on top of data package, you have a very solid foundation. You get free software, you get free validation, and you can really focus on the things that are important to you rather than doing all the reinventing of the wheel of naming all the generic stuff. So there's a number of community standards out there that are already using data package. The one that has been introduced at this meeting that you all know about is Darwin Core Data Package. ChemtraDP is also using this, but there's through a whole range, and these are only the ones based in science. There's also one in the governmental sector or the economic sector where car sales can be expressed as data packages, and they have community standards around that. So finally, how can you contribute to data package? Because this is work that is just like TEDWIC done by volunteers. There is a data package working group who is assessing new proposals and how to extend the standard, but really keeping in mind that it needs to be generic and extendable, so it cannot be too specific, but it's like finding things that could be useful to a whole range of communities. Helping with the open source software that is built, the Python, R, and other packages. But I think the easiest one is to start using data packages for your data sets. And like if you have a generic data set that doesn't really fit the TEDWIC standard, but you want to kind of describe it in a fair way anyway, that is what data package offers. Maybe just like me, you'll get really into these things and you want to help the foundation of all of this as well. Thank you.
Thank you, Peter. Unfortunately, we don't have time for questions. So I'll introduce the next speaker, Kendra Earl from the National Ecological Observatory Network in the U.S. Sorry.
Oh boy. Does this have a, this is just a mic? Oh, the clicker's right. Thank you so much. Oh, there's so many things to hold. Okay. Hold on. Yeah. I'm gonna do the things. Okay. All right. Hi, everyone. I am Chandra, and I work at the National Ecological Observatory Network, where my job is really to manage the data from our biodiversity samples. One of my focuses is on making that data easier to find and use, while using data-informed decisions to, of course, suggest and implement changes to our web systems. So that means I think a lot about spend a lot of time thinking about usability and how people are interacting with complex data portals. And so that's what sort of led me to this talk, in that I've been looking closely at how people actually use our site compared to how I expect them to. And I wanted to share some lessons that I've learned, especially for other developers and, of course, the front-end devs in particular. All right, so before, principal, this, all right, well. Okay, well, principle number one here is going to be how we really use the web. We tend to design things like this, where we expect people to come to our sites, we expect them to read all of our carefully crafted text, and really think about where it is they want to go next, click on that and make a decision and then move on, right? The reality is that is not at all what happens, right? The reality is that kind of look around feverishly for anything that is A, vaguely interesting or resembles what you're looking for, and B, is clickable. And as soon as you sort of find a halfway decent match, you click on it. And if that doesn't pan out, you sort of back up and try again. One of these rules is we don't read pages, right? We end up scanning them. So again, designers like to build things like this, where we've got all the information very prettily laid out for people. But what actually happens really depends on what kind of user is actually on that page, right? And so this really depends on what your goal is for that page. So for example, this is an airline ticket, or this is a airline, biztravel.com, woo. This person wants to buy a ticket, so they're only focused on some things. Versus this person, how do I check my frequent flyer miles? They're just focusing on those things. The second point here is we don't make optimal choices, we satisfy, which is this idea that we only go insofar as much as we're going to make effort, right? So in this value effort chart, we're going to go good enough. We are not going to go all the way to perfection, especially when it comes to the web. And that's because, well, there's really not, these aren't high value stakes. It's very easy to, of course, sort of use a back button, so we're more likely to sort of click around. And lastly, we don't figure out how things work. We kind of muddle through, right? If you've ever used a website, you're kind of familiar with this. So the idea here then is, well, if people are not going to, sorry, I must have like an old version of this on here. So what do we do? So if your users are going to act like you're designing billboards, you might as well go ahead and design really great billboards. So the first thing that I wanted to talk about here is this idea of design for the table, not the kitchen. And, oh my gosh. Design for the table, not the kitchen. And the idea here is that, when you are sitting down at a restaurant and someone brings you a menu, it would be really, really complicated if the menu included a lot of things like, the ID numbers for all of the ingredients that are in that are in the meal, the prices, where they're getting it from, blah, 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 blah. But on the other hand, you know, we've all, of course, seen menus like this where they don't give you enough information. And so what you're trying to do is you're trying to design for the users that are on your site. So this is the idea of design for the table, not the kitchen, right? The kitchen's going to need much different information than your primary users are going to need. And so this is an example of, so all of our examples come from our own site. I'm not trying to call anyone out here. So this is an example of what our search form used to look like, right? It's very complicated. There were a lot of forms, and that really got confusing very, very quickly. And so what we ended up doing is sort of trying to abstract this away a little bit by, you know, of course, adding those accordions and just making it a little more simpler for our users and not sort of overwhelm them with all of the available information that we could have in our databases. So rule number 2 that I've sort of learned here is reduce technical terminology. So of course, we're all scientists. You know, we like to use big terms a lot of the time. That being said, of course, you know, our users do tend to be research scientists. So there is a little bit of balance. We can, you know, sort of push the envelope here a little bit. But one thing, so this is, so like iNaturalist, for example, right? So on our users tend to want more, I say our, Neon's users tend to want scientific names when it comes to looking at these taxa. But if someone like iNaturalist, whose general audience is going to be a bit more general, is going to really focus on the common names for these, right? So that's just an example of how these are a little bit different and how you're designing for your users. This is an example of some change that we had to make in our site once we implemented some user testing. So we quickly realized that our site used the term collection a lot. And if you're in a natural history museum, you know what a collection is. You know, that's kind of what we use as the term to describe, you know, these like chunked bits of different samples. And we quickly learned that because our users are ecologists, essentially, and are not focused on natural history museums, we had to change that word collections to sample types because that makes things just a little bit easier. People inherently understand what a sample type is versus a collection. So this is what this used to look like, a list of all of the different collections that we manage versus, hey, okay, fine, here's the sample types. Again, we sort of abstracted that away a little bit and added those accordions to make it, again, a bit easier. And lastly, keep the noise down to a dull roar. You know, there is such a thing as, of course, being too overwhelmed on a site with all of the information that you can provide. And so an example of how we managed this was we used to have, so the example, this was our checklists module that we had. And in our checklist module was really, really great because there are all sorts of these taxonomic filters and options that we had available to us. However, for, again, our site, our users do not need all of these. And so this was just providing a whole lot of noise that was kind of unnecessary for our users. So what we decided to do is like clean this up a little bit and again make this just a little bit simpler and a little bit more easier for people to read and understand. Last in this piece is hold their hand or better yet do it for them because I learned, yeah, users are dumb, right? You can put a giant button on your freaking front web page, which is exactly what I did. So this was, our primary service that we provide is providing loans to people so they can get our samples. And so I put a giant button on our website that said, hey, request your samples here, please, 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 dear Lord. So this linked out to 2 different forms, one to request a loan and one to request archival services in case you wanted to archive your samples with us. But again, user testing, we quickly learned that that was not working. People very quickly forgot that that even existed on the front page, and so they'd be going through our site and be like, oh, I don't know how to get back to, I don't know how to get back to our loans. How do I do that? And we'd ask them, okay, well, how would you go about doing this loan? And they would say, well, I'd probably email a collection manager. And I'd be like, don't do that. Please go to our form. And so what we decided to do was, we decided to make this very, very obvious, and we put this link in a sidebar that was available on every single page. Every single page in our site, someone can get to this. And we also renamed it just so that we don't have to have this little blurb of text trying to describe what that button is. So again, just like that millisecond of thought, those milliseconds of thought generally add up, and just reducing those is really our job. Last principle number 3, omit needless words. Number 1, yeah, as we learned, people do not read website text. That's like kind of like rule number 1 when it comes to user experience on web pages. Again, we as scientists are very, very wordy, and there's some exceptions to this rule, especially if you're talking about news articles or research papers, that's fine. But generally, people do not read text like this on web pages, and we tend to do this a lot. I tend to do it a lot. And so if you have to do this, which we do, we have very complex information on our sites, go ahead and at least make it very easy for them. So format that text to support scanning. And what I mean by that is adding headers in, using bullets wherever you can, just like really making this easy. Because again, we don't read, we scan. As long as you're making it obvious what it is that each of these are talking about, make it easy for your users to sort of get that information. Last, simplify aggressively. So we sort of learned that, we sort of learned that when in redesigning, it is very possible to cut about half of the text on your page and still get your point across, right? And so, the idea is, of course, I'm not saying don't use words. Of course, please do, use words. But the first thing that you can do to make your page simpler is go through and just take an axe to your words. Please do. And then the last one, instructions must die. No one's going to read them, right? Our job as website designers is to try to show people what they need to do through clicks and interactions and visuals versus instructions. Again, I understand sometimes we do have to do it, but at the end of the day, again, we've learned people do not read. What happens is people again tend to muddle through. If they can't figure it out, they'll go back and then they'll read the instructions. But on very first glance, people do not read instructions. So I think that's my 10 minutes. And so I just threw these all up here in one slide in case you want to take a picture of those and sort of think about how it is that you're designing your web pages, or maybe you want to redesign these things. And of course, if you have any questions, feel free to email me.
Thank you, Kendra. I was told that Jimena is not here. I just want to make sure. Oh, you're going to do the talk? Oh, okay.
So, hi everybody. Yeah, Jimena is not here. She actually cancelled after submitting the abstract, but somehow it made its way in the program. If you really wanted to know about the GF Bio submission system, just see me afterwards. We can talk about this. We work on the same project, though not in the same institution, but I might help you if you have specific questions about that.
Thanks. All right, so we'll move on to the next speaker, David Divas from Syntropia in Guatemala.
Well, hello everyone. I'm going to mix it up a bit. I know that we're almost close to lunch. It's Friday, so I'm going to make more of an emotional, philosophical appeal and not use any fancy spreadsheets or data points or anything like that. I come from the Society for Investigating Nature, Technology, and Regeneration via Open Agroecology. It's an indigenous-led movement in Guatemala. I'm part indigenous as well of the Xinca, and I have just a video, beautiful video, to kind of put the message in a more emotional response. And so if someone press play. Thank you. Well, yeah, so with this talk, I want to put in a specific concept of how the indigenous actually view the world, not just as a linear system, not just as a collection of separate data points, but as a unified, interrelated, connected being. That's why when you talk with indigenous, and I've had the chance of having informal discussions with over 60 different indigenous groups across the Americas, I can say, at least from my perspective, that they don't view the world as we take, we gather, we process, and then we move forward. Instead, they see it as a sunrise, as a sort of cyclical thing that happens every single day. When you ask them, for example, what do you think of this point? And it is a sacred point, which they take usually as mountains, caves, which are personified. They're not necessarily exactly something that you can put a dot on. They are always going to be a part of. And in this case, this is from Guatemala. This is a specific point, ceremonial. If you turn your head a bit, you can see the Mayans' face, is what they say in the colonial, but has another name, Cerro Cristalinas. And I waited 7 years to take this video, specifically because I was told by somebody, hey, there's a sea of clouds eventually. And the way I got to this point was not through looking at the weather, was not by doing simulations of probabilities, it was just simply by a sense of being, of which I've managed to somewhat acquire over the last 10 years I've lived in this area. And so what am I saying? That essentially Western, we have, as Westerners, we also have a tradition of Cartesian dualism, where we look at things as a separation between mind and body, between us and the rest of the world. The indigenous do not see this. They see it as a unified perspective. If you were here yesterday for the beautiful talk, there are concepts that are shared. Pachamama is one in which, very may have heard of it, which doesn't necessarily mean an object. It means a place of being, a place of existence of which you are a part of. And so when you go out in the field, I just simply ask of you, when you look at the world and you see it and you ask the indigenous, how do they see it? You take a step back from that tradition that we've had for hundreds of years and maybe reflect on the way they've seen the world for millennia. So with that, I end my talk.
Thank you so much, David. I think we have time for some questions.
groundwork, I guess, and then we have 700 local governments who are on the ground working with developments and local and regional management. So when we did our usage review, we found that we had 180 agencies at all government levels using the Atlas. Over 3,000 users use it as part of their regular work, and not just the departments of environment or environment-related stuff, but also ag, health and education, and fire management, and quite a few more. In terms of industry, we found that a lot of environmental consultants are citing the ALA on EPBC submissions, so a lot of them are when they're doing an environmental assessment, their first port of call is a desktop study on the Atlas. So we had more than 500 business units, users, and many of them said that ALA was really critical to their business. What's the other sort of significant thing about that? I can't remember. So we built our taxonomic backbone for Australia. So we have the Australian Biological Resources Study that puts together a national species list at the core. So this is really similar to the Catalogue of Life story. We have our core data sets that make up the NSL and the faunal directory, the plants lists, the mosses, fungi, etc. Then we we make sure that we add in all of the jurisdictional lists. Some of those describe species, use different names, have spelling errors, different synonyms, those sorts of things. We need to add our sensitive lists in there, our biosecurity lists, which don't make the national lists, pests and weeds and stuff, and migratory. We bring in part of the New Zealand Organism Register because we manage the Australasian Virtual Herbarium, and the Catalogue of Life to pick up all the little things. And with that, we merge all those together and build a names index for Australia. Once we've done that, our names index, and I think I'll read this from the bottom up because that's chronologically how it works. We take our names index, we put it into Checklist Bank, we do reviews there, and use the diff tools to compare national and state taxonomies. Of course, it sits behind our name matching API so that we can catalogue incoming occurrence records, and it forms the basis of our species pages, so like our Australian Species Encyclopedia information. Moving on to sensitive data management, we've had one of our oldest pieces of software is called the Sensitive Data Service. The SDS takes in rules from a species list from each state, which provides us with rules for generalisation or obfuscation of species records. So when we ingest data, we obfuscate particular species records according to those rules. And then we publicly share the obfuscated values, and we retain the high resolution information, and that can be applied. People can come and apply to us for access. As we've been looking at how to redevelop that software, we've been working on this thing we call the Restricted Access Species Framework, which whereby we've been trying to get all the states to agree on a national approach to these problems, national approach to, they all obfuscate different species differently and have different approaches. A cool thing we've done as part of that is build a system that will generate data sharing agreements. So given a metadata statement about sensitive data that's available, someone can request access, that access can be given, and there's a DocuSign system, and a sharing agreement can be spat out. And so that's been a lot of great work. We're also working, ALA is also leading a task group for TADWI called the Sensitive Species Task Group, and we are trying to address all, the data standard, people aren't using the existing fields really all that well to describe the way that data is generalised before it's supplied to the ALA and GBIF. So this group's building on vocabularies for how, for sensitivity treatments and sensitivity reasons, and there's a lot of interesting work coming out of that. So they're also working, they've sort of finalising those vocabularies, I believe, and then building an extension for existing Darwin Core archives, plus looking at how to fit them into the model. And anyone's welcome to join that or catch up on that work. biosecurity alerts we've built over the last couple of years with our Department of Ag. So you can see here, this is what it looks like in the email. We have, as data comes in through, people can be alerted about new records coming into the atlas. So they're open to anyone in the biosecurity sector and used by 70 related agencies, which is quite incredible. I didn't know we had that many agencies. And there's some other stats there. The way it works is the data comes into the atlas, obviously. iNaturalist, Feral Scan, these sorts of apps come in weekly. The data's ingested as usual. The agent will give us a species list that they want to target, that they want alerts to be delivered on, and they get those in their inbox every week. That's been great. We've had a few really important incursions notified through this process. A few insights into that. Biosecurity is quite different to biodiversity data. The associations and impact information is really important. The data tends to feature in cultivated areas and private land. And we require flexibility in how we approach this. A lot of things have come up with data sharing, so pests and weed naming is difficult. There's scepticism about accuracy and value of citizen science data, but there's really limited sources of non-citizen science data in this area. Last of all, eco-assets is a project that we've worked on to deliver data into integrated reporting. So that's been a collaboration with some of our sibling research infrastructure agencies and marine and terrestrial monitoring, and we've produced data products to support State of the Environment reporting in 2021. So we integrate data all in one great big data set and make it so that you can use it at national, state and territory scales. That was 2021 we first did it, but every year we've been, I believe that's a 5-yearly reporting exercise, and every year we update the data and make that freely available as well. So I've got some links in my slides if anyone's interested. That's all there. There's some webinars and some of our hubs and help pages that might be useful, but I'm happy to answer any questions at any time. And I want to thank my co-author, Cam Slatya. Thank you very much.
I think we have time for one question.
Nikki. Oh, bring it over here.
I'm interested in, is that okay? Yeah. How you, if you're dealing with sensitive data, are you obfuscating images? Like I'm thinking if you've got like a herbarium specimen image, I mean traditionally we thought who's going to look at all the images, but now we've got AI, so do you obfuscate those?
So the question is whether we obfuscate images, say of herbarium sheets, might have sensitive information in the labels. Do we obfuscate those as well? We learnt this lesson a few weeks ago and managed the problem sort of manually, but we're redesigning our new system and we'll have to, we'll just have to find a way towards that. But yeah, because we hadn't realised that that some of the information was just there in sheets. Cool. Thanks.
All right, thank you so much. Our next speaker is Ricardo Segovia from the Instituto de Ecología y Biodiversidad in Chile.
Thank you. Oh, presenting after Peggy feels like I'm coming from the past. So today I'm sharing with you the progress of the Biodata project at the Institute of Ecology and Biodiversity in Chile. So our mission, as you can see in the figure, is to, try to bring the chaotic biodiversity in ordered data sets, data cubes. Like, we are working on that, and we started with herbariodigital.cl, herbariodigital.cl. And the goal of Herbario is to integrate, digitize and integrate the biological collections in Chile, starting with herbaria. We started with just 2 herbaria, Conc and ULS, and we have integrated recently 3 new herbarias from the University of Chile. So we are now a real network of herbaria in Chile. And our numbers are really are so good. We have more than 130,000 digitized specimens, which is a lot considering Chile is not a big country. And that specimen are come from almost 4,500 species, different species. So we feel really, we feel that this is a really success experience in integrating biodiversity data. And for our funding agency, it's also a really good experience. They are happy as well because every time we integrate or join a new herbaria in our network, for them it's an event of knowledge transference. So that's important for them. As you can see in this figure, here we have specimen per species, and we have almost 80% of species with the digitized specimens, and we have more than 55% of species with more than 5 digitized specimens, which is the minimum number to do analysis like estimate the distributional range. And you can see here we have 5 herbaria contributing with data to the herbario digital. This is very good, and the most important thing for us is that we are integrating the data set in a standardized list of species. We are working with the catalog of vascular plants of Chile to integrate every specimen. So this list, the x-axis represent our catalog. So, and this catalog is curated by a community of taxonomy specialists in a synchronic way. So we created a platform to the taxonomist team to edit the catalog, which is our taxonomic index, and we are recording the changes, the nomenclatural changes, or the problems we are finding during the process of digitization. So this logbook is really important for us because it's a measure of the work we are doing. So then, eventually, we are going to systematize this information, and we will be able to say, well, we helped a lot in improving the taxonomic index, and during we were digitizing specimens. Also, we have our first scientific product. We wrote our first paper. And in this paper, we compared our taxonomic index with a global taxonomic index. So we downloaded the catalog of life, and we filtered it with the species with occurrences in Chile according GBEF, and we created a call for Chile, a catalog of life for Chile, and we compared it with our taxonomic index, and we estimated a really simple measure, so the number of taxa, of species in every genera and family. And we have a lot of differences. In some cases, the global catalog have more species than the local catalog, and in other cases, the local catalog have more species than the global catalog. And this is important for us. This is matter because the taxonomic index is the way, the only tool we have to organize our biodiversity. So we have to deal with this difference, with these inconsistencies. Because our vision is as following. The semantic relationship between a taxonomic name and the proper natural taxon in the nature is the key for integrate biodiversity data. So if we are confident with this relationship between the taxonomic name and taxon, we will be able to integrate ecological information like Conantera ursulata is an endemic species of the Desierto de Atacama, and it is classified as an endangered species. And we also can integrate images and another kind of information. But here is the key. And in our vision, it's a realistic goal for Chile, at least, or for vascular plants of Chile, to have a one-to-one match between names and real taxons in nature. We know in another countries, in another region, it's a difficult goal. So in Amazonia, dipters in Amazonia is going to be difficult. But for Chile, for vascular plant in Chile, is a possible goal. So we trust in our system now. We are able to integrate information. Coranthera ursulata, the same species, is an herb from the Tecophyllaceae family. It's a grass. We have the photos integrated, and we have the occurrence integrated, and also we have national administrative information about the taxa. So we have really happy with this goal. But we now have a more challenging project. We have to create, we want to build a living atlas for Chile, and we want to do it with a local built and maintained taxonomic index. And we don't have anything similar to a catalog of vascular plants for the whole biodiversity, fungi and animals at least. So we have to work on that, and we started with this. In this case, we created a preliminary data set. We did the same. We download the catalog of life. We filter it with the occurrence in Chile according to this, and created a first draft for the catalog of Chilean biodiversity. And then we replaced the section of vascular plants in the global catalog with our own catalog for plants. And we now want to incorporate the community of specialists in taxonomy to improve all the sections of the catalog of Chilean biodiversity. And this is the plan. We already have Tracheophyta. We replaced the global catalog, and step by step, we want to incorporate new group of specialists building and maintaining the catalog of life for Chile. And we started. We already have a first version in the cloud. We have to solve some problem with the database, because the database that we created for vascular plant was easy. It's really easy to work with just one nomenclatural code, but we flexibilize now the system to be able to work with every family in fungi, animals, and plants. And also we improved our book log, because we think at the end of this job, we will have really important information about the changes, the nomenclatural changes, the typos found during the process of creating the taxonomic index for Chilean biodiversity. This is. Thank you.
I think we can fit in one question. Anyone has one?
Just how about your participation in GBIF?
It is a problematic situation, because it's not my participation, but my country. But people, well, my country have a node, a GBIF node, but people who works in the collections is not really confident about to share the data sets in global systems. But we have worked on it, and we combined a lot of people, and actually they are more open now to share the data sets in GDIF, and it is easier now because we can help them with the standard formats to do it.
All right, great. Next, we're going to move on to Stephen Formel from Formel Data Services in the US.
Thank you. Give me a second. Okay, and this. All right, so I'm actually probably most nervous about this talk more than anything else that I've done. I mean, it's in part because I'm standing up here possibly completely ignorant about what I'm about to talk about. So, but this is one of the reasons I'm giving this talk, because I had these ideas and I wasn't able to really find satisfactory answers. And it could be that there are people in this room who can tell me, Steve, this is how the world works. So in my experience as an academic, as a government employee, and now as a consultant, I have found that it's really, really difficult to hire data managers. Frequently, we can only hire them when there are large tasks, large amount of funds, and it's usually quite a bureaucratic process to do so. I've also noticed that in the literature, we've been advocating to change that for decades, and yet it seems that either science and institutions either can't or won't hire data managers, generally speaking. So I have this idea that, along with my co-authors that we've discussed, is can we improve that reality by embracing data management as more like a gig work type thing. So treating data managers more like tradespeople, like an electrician or an accountant, rather than as this sort of more complex position. So I did do some literature searching. I'm not just speaking from I'm not just making this up. And so I'm using these two examples as two examples of where there was some advocacy for this. In 1999, in the OECD report that begat GBIF, they did note you require specialized staff to do this. You're not going to just be able to do it, with the current capacity that we have. And then in 2024, Gunz et al. Wrote this really nice paper talking about national biodiversity data infrastructures and what are some excellent qualities they should have. They noted that having it at the national level allows for sort of a more custom implementation. And so my argument is that we should go one step further and have a network of data managers that can be implemented for custom roles on different projects across all of our nations, across all of our institutions. I also want to note that in doing my sort of informal literature search, I found that a lot of times when we advocate for increased capacity, we really emphasize technical capacity instead of talking about human capacity. And so I don't know if that's, we're just sort of being polite. It can be an uncomfortable conversation to say, really, we need more people, but I had trouble finding many papers that specifically said people are the problem, not the computers or the other parts. So this is my view of how data management staffing traditionally works. Up top, there's probably maybe a couple people in this room who have full-time data management staff, and it works really well, and that's fantastic. We should all be so lucky. More often what happens is, we hire new staff when there's a specific project that comes on board and we have more money, or maybe we take our permanent staff and, shuffle their roles, shuffle their responsibilities. I've definitely been invited to projects to be a data manager, and then, I get the credit on the paper and those kind of fun things. And then, but more often than not, right, many of us have been here, right, the warm bodies, where it's like, you're going to learn how to do this. We're going to do it together. So, so again, this is my view of it. I'm not saying that it absolutely has to work this way, but I do believe that there is some truth there. Let me see if there's any other notes here. No. So, whoa. Too much at once. Okay. One of the things that's driving this situation is funding organizations, and this is not new. We've known this for a long time, and sometimes there's good intentions behind that, and sometimes maybe it's just ignorance of how the world is changing. Many of us as data managers and as people who are savvy with computers can work across geographical borders. We can work across institutions, projects with a lot of facility, and so maybe this is something new for a lot of funding agencies. I took the time to peruse the funding policies for the NIH and the NSF in the United States, where I live. And what I found was that there are some constraints from the funding agencies, but then even more so, they'll say, but on top of this, you must comply with your institution's funding constraints. And so, for example, I know I was talking with Hank Bart earlier this week, where he was saying, here's the way that I have to do it. Here's how I can hire people. And so, again, at your institution, it might be easy. Maybe you don't deal with this stuff, or it might be quite difficult. Some of the noteworthy things I found in the policy is that you have to be able to justify these things up front. And we as data managers might be inhibiting that because we don't make it clear what services do we provide, how much do they cost, right? So perhaps if easier for people to say, this is how much a data management plan costs, this is how much it costs to mobilize 10 data sets. Then they could incorporate that into their planning. These funding agencies also try really hard to protect employees by avoiding freelance work in a way that can be abusive. And yet I think that same well-intentioned policy is keeping projects from being agile in the way that they flex the people around them. So for example, I forget if this was both NIH or NSF, but at least one of them said intra-institutional consulting is prohibited. And so that means the people you know best, the people down the hall from you, are only allowed to be on the paper. You can't pay them. And that's pretty ridiculous, right? You have to go to another institution to be able to pay somebody, say, to publish your data. But again, two things here. This is my take on it. Please read the policy. I'm not an expert in this place. And then I think we all have to work within our own institutions and our own companies to realize what sorts of barriers are we unintentionally creating for hiring people. And so what I'm proposing here is an alternative approach. It's not complex. It's just saying, can we plug people in, sort of opportunistically in different parts of the data lifecycle for small jobs, right? It's great. I'm not saying we should replace the big jobs. It's great when you can bring on a full team, with a big budget and do end-to-end planning. But perhaps, if you just need a little thing done, it'd be great to pull in a person at that moment. And so this partly evolved from my friend Kit Lure's thinking about microservices in software engineering. This idea that you have different components that you just stack together, and that's what makes your functional system. So Abby and Benson and I, we came up with this idea of the people stack, right? That you can just stack people together, and this is how you make a functional data management system. So importantly, it's modular, it's on demand. As data managers, again, we have to make it clear how to buy those services and make that easy to do so. And so in this way, it's like a gig economy. I realize gig economies, things like rideshare services, can also be abusive, and so I'm aware of this, but I think it's still worth investigating. It doesn't mean, again, that it's exclusive of traditional ways of operating. We can plug people into any of these situations, right? If you're at the warm body stage, maybe you just need a little expertise to come in and sort of guide you towards solutions. If you're at the full-time data management place, maybe you're a little under capacity for a certain project and you just need to bring somebody in to take care of that one task. The most important thing here is it has to be easy to hire these people, otherwise it's not worth doing. So the benefits for science as I see them is, it enables us to be better with allocating our resources, especially funding. How many people have had, you get to the end of the budget year, your fiscal year, and you're like, oh, we got to do something with these $2,000. I don't know, let's make something up, right? And imagine if you could instead use that $2,000 to pay down some of your data management technical debt. That would be amazing. Little by little, we make the world better. You can also do things like, if you have a postdoc position, you could carve off some portion of those funds for the data management activities, thereby allowing you to focus on the scientific expertise of the postdoc rather than finding some unicorn that's amazing at both, right? And then finally, too, you can align your data management priorities with your scientific values and also your cultural values of your lab and your institution. There are people who are never going to be interested in doing data management, and that's okay. Just like they can pay for things like sequencing, mass spectrometry, they should be able to pay for data management. And then I think for the people in this room, this might be the part that is most of interest. It supports more flexible career models. Many of us have had to jump around from institution to institution, job to job, to try to create a living. And sometimes that means having to leave the people and the places that you love. And I think that's a real problem in science. And I've had the opposite experience where I've been fortunate enough to stay around where my family lives. And in that sense, I think this is a step towards allowing more scientists to accomplish that. So, zooming out, this also totally aligns with global biodiversity goals in Target 20 and 21 of the KMGVF. So we have these big questions. How can nations increase their capacity? And so what I'm arguing here is it's not about increasing money, it's about using that money more efficiently and allowing people to use it more efficiently. Coming back here, my purpose here today was to provoke people. I want to have a conversation about this. I think we can stimulate a market from which we can benefit as well as through which science can improve. But it's an idea, so let's talk. Now, the best slide is coming up here. I have a company, my company, ready to test these ideas. So, no, really what I just wanted to share is that my colleague Abby Benson and I, we both left the US government in the spring and started this company. we are available for work as well as continue to just do science in general. We're both very enthusiastic about open science, and that's all I have to say. Thank you.
All right, thank you. No time right now. Sorry. Okay. We'll do one question.
I appreciate that, and it's actually not a question, it's a comment. What you just said has come up in spades in the unconference that just happened this morning. The key person to contact will be Nikki Nicholson. She is pulling together a group to put biodiversity biologists, scientists, and data people together to advance careers in both directions.
All right, our next speaker is Arthur Chapman from the Australian Biodiversity Information Services.
Good afternoon, everybody. Here we come to near the end of the week, and we've come to probably one of the most important topics, biodiversity data quality. The biodiversity data quality, we've just created a standard, or proposed standard, that we've been working on for about 11 years. So we'll give a brief introduction and overview of the data quality standard, the core components and criteria, and future directions. And we've got AI to do it for us.
You know, for more than a decade now, a really dedicated group has been tackling one of the toughest emerging in biodiversity science, data quality. And all that hard work has finally led to something pretty big, a new proposed standard called BDQ. So today, let's dive in. We're going to look at what it is, the story behind it, and what it could mean for all of us. So here's our roadmap. We'll kick things off with the problem itself, what I'm calling the quality conundrum. Then we'll follow the task group's quest to solve it. After that, we'll properly introduce the BDQ standard, pull apart one of its tests to see how it works, and finally, look at how this could create a whole new data flow for our entire community. All right, so first things first. To really get why the solution is so important, we have to start by getting on the same page about the problem, a challenge that, let's be honest, has been a thorn in our side for years. This sentence, right here, is from the original charter for Task Group 2, and it just nails it. It basically became the guiding principle for this entire effort. The idea was simple but powerful. Getting the data is one thing, but the quality of that data, well, that's the real barrier to actually using it effectively. And to make this really concrete, just look at this number. In one analysis, someone looked at the Darwin Core country field and found over 80,000 distinct values. 80,000. It should have had, what, maybe 250 standard entries? This is the exact kind of chaos that can bring large-scale analysis to a grinding halt. So how do you even begin to solve a problem that massive? Well, you get a dedicated team together. And that brings us to the Data Quality Interest Group's Task Group 2, who basically signed up for this long-term mission to forge a real community-built solution. And believe me, this was a marathon, not a sprint. The group was formed way back in 2014. They spent a solid decade gathering tests, holding critical workshops, getting frameworks published, and then making one last big push this year in Seattle to get the standard ready for submission. A ton of work. And of course, that kind of work doesn't just happen. It was driven by the sheer persistence of a core team. This standard just wouldn't be here without the foundational contributions of Lee Belden, Arthur Chapman, Paul Morris, and John Wittray. And we also have to give a huge shout out to the significant early input from Alex Thompson and Paul Zaraglio, and the more recent and vital contributions from Yin and Gang. Okay, so after that decade-long quest, what did we get? We got the proposed biodiversity data quality standard, or as we're all calling it, BDQ. It's really designed to be that common language for data quality that we've all needed for so long. So what's at the core of BDQ? It's a suite of 110 distinct tests, each designed to work on a single record. And you can see they're broken down into 4 main jobs. The vast majority are validation tests, checking if something complies with a rule. But there are also amendment tests that can suggest a fix, measures for things like statistical summaries, and issue tests that flag a problem for a human to look at. When you boil it all down, BDQ is both a shared vocabulary and a toolkit. It gives all of us a standardized, consistent, and transparent way to talk about, evaluate, and even improve the fitness for use of our Darwin core data. Now, to really understand how this works in the real world, we need to pop the hood and take a look at the structure of just one of these tests. This is really the anatomy of the toolkit that people will actually be using. Every single one of the 110 tests is built the same way. Each has a GUI, which is a stable, unique identifier, plus a clear, human-readable label. It defines the dimension it's working on, like space or time. It can even accept parameters that let you tweak how it behaves. But the real engine, the heart of the test, is the specification. This specification field, this is what gives the standard its muscle. It's a totally unambiguous, machine-readable description of the test's logic. So for this example, a simple check on a month value, it spells out every single possible result. What to do if the field is empty, what it means to be compliant, and what to do for everything else. It's this level of detail that makes BDQ so robust and so implementable on any system. So what's the big picture here? What does this all mean for the future? How is this actually going to change the way we work day to day? Well, this is about creating a fundamentally new and better data flow for our whole community. The real beauty of BDQ is that it's not just for one part of the process. It can be used everywhere. It can help inform better data capture from the very beginning. It gives aggregators a standard set of tests to run. It gives us all a framework for flagging issues or even suggesting fixes. And maybe most importantly, it gives the end users, the researchers, clear, consistent reports so they can decide if the data is fit for their specific purpose. So why does all this matter so much? Because when we all use a shared standard for quality, we get consistency. Consistency builds trust. It makes us way more efficient because we're reusing tests instead of reinventing the wheel. It sets a new baseline for what we consider best practice. And it unlocks a new level of collaboration and interoperability that just wasn't possible before. For a decade, our community has been forging this thing, this common language for quality. So now that it's here, the really exciting question is, with this foundation in place, what new frontiers can we explore? What bigger questions can we finally start to answer together?
So we're at the stage at the moment where the standard is out for review, and some of the reviewers are in this room, and we've been getting some positive feedback. So shortly after that, in early next year, we hope that it will go out for public review, and you can all do it. But already you can start implementing it into your own systems now if you want to. And we're hoping by the TADWIG meeting next year, we'll have lots of people telling us all their success at implementing this. We don't want to know the failures, but you can tell us those as well. And then there's a maintenance, like TADWIG standards, a biodiversity data quality maintenance group will be established, and that will maintain the standard and also help with ways of adding new different tests into the system. In conclusion, we believe that it's a fairly important stage in biodiversity data management that we now have a standard that we can, or we will have a standard that we can all follow, and we'd like to see it built as early in the data line as possible by the collectors or the data managers in museums, rather than leaving it up to GBIF and the ALA, etc., to correct the data. It's all available on GitHub with the standard itself. A wiki explains some of the stuff. There's the BDQ tests themselves, the 110 tests, I think, and a link into the information. Thank you.
Well, thanks a lot to you and to Notebook LM for that great presentation. I was wondering about the scope of the biodiversity data that is targeted by this standard. Is it mostly Darwin Core archive data, or does it extend to other type of biodiversity data?
It's fully based on Darwin Core. All the tests are based on Darwin Core. But as we've discussed with others and some of the reviewers, in the future, there's nothing to stop people adding other tests from other areas. There's a very structured format, and for developing new tests that follow the exact same format, and it should be fairly easy to add different types of tests into different types of data, and for maybe small use or global use. It's up to the future.
All right, thank you so much, Arthur. Our last presenter is Ed Baker from the Natural History Museum in the UK.
Not really sure how you follow that one up. So I'm just going to talk a little bit about the last year of activity from the Audiovisual Core Maintenance Group. And it'll be quick so we get to lunch. Audiovisual Core is one of a suite of TADWIG standards, and it covers like multimedia, mainly in a descriptive sense, but also providing a framework where you can assess the suitability of those media for specific tasks. We are in the process of starting an AI readiness task group, so if anyone's interested in that, be interested to hear from you. One of the big things we were hoping to get done, or at least get into public comment for this meeting, was the 3D task group's work. So we have a new term name, or a new value for media types. So we can start supporting digital 3D resources like CT scans, all this kind of stuff. This will probably get to public comment in about a month's time, with a much broader suite of new terms and new functionality for the standard, so keep an eye out for that. We do all of our stuff on the Audiovisual Core GitHub, so you'll be able to find that. One exciting thing we got is a new term and a new controlled vocabulary for content description, so describing what's in individual media items. Which in itself is quite interesting, but when combined with the work we did last year on regions of interest or segments of media types, you can start doing some really interesting work. And the idea is you can identify like bits like labels, scale bars, or like, as an acoustics person, like bits of audio within a recording. The idea is like, yeah, you can just label these bits and go like, I think when we start getting the AI readiness task group and all these other bits of all these threads have been working on in the next year should really come together. This is a classic bit of audio. It's like, this is a section of audio where people are speaking, so it has like privacy concerns and other kind of things you wouldn't want to necessarily make public. And starting to like create a way where we can identify bits of images we're willing to share, bits which we want to keep private. Is a particular work we do in the museum where we're recording audio in our gardens. There's some really big concerns about what we can make public, and this kind of gives us a framework for doing so. This work has been approved by the maintenance group, so will be released in the next few weeks. One thing that's come up is we've never created a class for media items. I know it's been discussed several times over the years, but the time has come. So as part of the Darwin Core data package, there's a need to create a kind of class term for media items. And it kind of makes more sense to have that in Audiovisual Core rather than Darwin Core. This will go to public comment possibly today or tomorrow. So keep an eye out for that one. And we really want to get this, or need to get this done within the 90-day comment period for Darwin Core data package. So this will be a 30-day comment period, and hopefully we can align everything there. And the year ahead. So we've got plenty of things going into public comment. We're kind of focusing on making or increasing the usability of the audiovisual core standard. One of the things we've been working on is kind of like usage recipes or usage examples for parts of the thing. One thing we've done a lot of work on recently is the confusion in rights and license. So we've been through lots of GBIF data on these terms, and there's a lot of mess in there. So providing some guidance on how those should be used. And also on the work Dan Stowell and I have been doing on audio in the standard. If you want to join in, we do almost all of our organization through the audiovisual core GitHub there. We'll be announcing the upcoming comment periods, and if you have any general queries or ideas, please do contribute there. We have a Zoom call on the third Wednesday of every month, and the details for how to join that are on the GitHub there. And I'm going to leave that there, but thanks to all the members of the maintenance group. Really couldn't do it without everyone's involvement. The contributors to the task groups, particularly 3D task group, because that's been a few years in the work and very nearly there. And everyone else who has contributed to audiovisual core. Leave it there.
All right, I think we have some time for a couple minutes for questions, if anyone has any.
Thanks, Ed. Have you any interest within the AV group on using voice as input for field notes and stuff like that, rather than deliberately recording human voices rather than ignoring them?
So the question is actually sections of deliberately, or human voices we want, which is kind of like the start of, so you do sound recording, you might often do a bit of introduction, like location, where you are, these kind of things. Yep, that's in the standard as a spoken description. And we have an awful lot of that in our collection. And I trying to transcribe that and do some other work with it as well. So yeah.
Any other questions?
I have a question to Peter about this previous talk, about the fictionist data packages. With the constraints, is it also possible to give like a warning level as opposed to an error level if something like doesn't really align, but it's, yeah, if the user says, oh, I'm aware of that, I'm still going to publish it? Or is it just a single error level?
So the validation is currently a single error level. What you do with that error, that is up to you. But it is, yeah, it is a full validation on anything that is not according to the constraints you have specified or you have specified in your community standards. Whether that is a blocker for publication or not is up to the tool that is doing that. So currently in the IPT for camera trap datasets, that's a blocker. But yeah, there's ways around that, but it's just a yes or no.
All right, are there maybe one final question for any of the speakers? I know some of them didn't get to have a question period. All right, well, it's lunchtime. This has been a packed session with a lot of very interesting speakers. So maybe we can just give one last round of applause for all of them.